Alright, so in this video I'm explaining just classic time discounting in economics, and in particular we want to be thinking about why are things in the future worth less. And to do this we're going to be thinking first about a cake, and then we're going to think about money and what are the different dimensions that come up with those two different factors. And then we're going to look at why do economists use a format like this one when we're discounting time. Alright, so first we want to do a thought experiment. So we're imagining we're offered two options. One is you could receive a cake from your favorite bakery today. It's this bakery down the street. You really love their stuff, and you could have that cake delivered today. And your second option is that you could have a cake from that bakery delivered to you in 1 year. And it would be baked that day. It would be the same cake, the same exact cake. And the question is, which do you choose? And the answer is almost everybody is going to prefer the cake today. Now, what that means is that we actually need a higher utility value for the cake today compared to the cake in a year. And so essentially what time discounting is doing is it's putting all of these things in the same units, because we know that your experience of this cake is going to be the same today as in 1 year, your actual momentary enjoyment of each bite of cake. You love the cake, it's going to be great. So we know that in the moment your utility is probably going to be the same between these two cakes. So we need to adjust the utility over time to account for the fact that people's revealed preferences are going to put a higher utility for the cake today. So to express the fact that we get the same momentary instantaneous enjoyment from the cake now as we would in 1 year, if that's the same cake from the same bakery baked on the day it's delivered, we're going to express that as instantaneous utility, which is going to be 100 every year. It's 100 today, it's 100 in a year, it's 102 years if the experience is the same in those 3 periods. But we know that people are going to prefer the cake today, and what that means is we need some way of translating this utility into units that we can compare to each other, because if everyone's always choosing this, it doesn't make any sense for us to use this to use an equals or an equally preferred sign. Really, we know for sure that the cake today is strictly preferred to the cake in the future, and so this doesn't make sense to have the utility for the 3 be 100, because it's not going to capture revealed preference. And how do we fix that? We fix that through the concept of present value. So the present value here is your value for the cake in a way that reveals your preference over time. So we can say for sure that the cake today is worth more to you, or is more valuable, or will always be chosen over the cake in a year, because the present value of the cake in a year is less than the cake today. And so what is the difference between the instantaneous utility up here, the 100, which is still true, and the present value? Well, the present value is the value of this cake from the vantage point of today. It's you sitting here in time today, thinking forward 1 year into the future, and that fact that it's distanced from you is going to actually impact its utility. Whereas this 100, both of these are true, this 100 instantaneous utility is when you arrive at the moment in 1 year, how much utility will you get from the cake at that point in time? So present value inherently has a time horizon looking forward, and it makes things comparable such that people's revealed preferences are going to match the utilities assigned to these things in time. Now at this point we can ask the question, why is it that people almost always prefer the cake today over the cake in 1 year? And there's a few reasons for that. One of the reasons is just going to be uncertainty. You don't know what's going to happen between now and 1 year from now. Your preferences for cakes could change. Maybe you'll stop eating sugar, you'll go on a diet. You could die, the bakery could go out of business. There's all kinds of uncertainties between now and 1 year from now that make the fact that you will enjoy this 100 utils a little bit uncertain. So because of that, it actually makes sense to have lower value on the cake from today's vantage point than you would if you were in the moment actually experiencing the cake. There's also just the psychological phenomenon of myopia. People are impatient. People like to experience good things right now, and they like to delay bad things until later. That's just a psychological principle. Now, time discounting can capture that and does capture that myopia that people have, but there's also other ways to capture it. In particular, hyperbolic discounting is a behavioral economics way of capturing it that's actually going to account for certain behaviors like procrastination and compulsive overeating and behaviors that you regret, for example. So time discounting partially captures people's myopia, but if you want to fully capture all the irrational behaviors that go along with our myopia, you should check out my other video on hyperbolic discounting, the beta delta discounting model, and it'll explain that more there. Alright, so what about money? Is there anything different in the picture if instead of looking at cakes, we were looking at money? And yes, there is. Alright, so now we're imagining the scenarios. You're given three options. You could get a $100 bill right now, you could get a $100 bill a year into the future, or you could get a $100 bill 2 years from now. And which do you choose? And in this case, pretty much everybody is going to choose the $100 bill right now. And some of the reasons we thought of before are still in play, like you could still die between now and then. The person who's promising you the money could die or go out of business or whatever between now and then. So there's still some uncertainty involved. But there's this other thing, which is the fact that you could just invest this $100 today, and in 1 year you're going to get more than $100. As a matter of fact, you're going to get $100 plus the interest that you accrue over that time. So, alright, so we have $100. If you receive this $100 today, you can invest it, and if there's a 5% interest rate, I just let R equal 5% for this example, then you know you're going to get $105 out of the bank in a year. And that's definitely better than getting the $100 bill in a year. And if you invest it for a second year, so you got the $105, you invest it for another year at 5%, you're going to have $110.25 in 2 years. So we know that these values, whatever present values we need to assign, need to capture this particular phenomenon. And this also means there's going to be a pretty precise way that we should construct our present value to capture for this specific opportunity cost of investing the money when we compare these different scenarios. What we're trying to go for when we construct this present value is the equally preferred sign. That's what we would like. Now, we don't have that right now because obviously 105 is preferred to $100, so we need to construct present values that will make this true. Alright, so I've come up with these numbers, and I've derived these numbers assuming an interest rate of 5% in the bank, and actually the rate of return captures uncertainty. It captures everything, not just the interest rate at the bank, but for simplicity, since we're walking through an example, let's just assume that the only thing that matters here is the interest rate that you could get from your bank, and that there is no uncertainty, there's no inflation and other factors to consider. So what that means here is that I've constructed the 95.23 by dividing the $100, or the $100 that we would get in a year, by 1.05 to account for the 5% interest rate. So 1 plus 0.05. That's how I've constructed this. And what that means is if I received $95.23 today, I could invest that money for a year and I would pull out the $100. So it means I should be indifferent between receiving $95.23 today and $100 in a year. If I can invest that at 5%, those are going to be the same dollar amount in 1 year. If you said you have the option between getting $90.70 today or getting $100 in 2 years, those are the same thing, because you could take that $90.70 today, invest it for a year, that's going to lead to you getting $95.23, invest it for another year, that's going to lead you to get $100. So you're indifferent between getting $90.70 today and getting $100 2 years from now. That's why we call this the present value. It's sort of taking, what if I got to $100 in 2 years? What would that be the same as if I were to receive that money today and just invest it and pull out the $100 in 2 years? What is this dollar amount that I'd receive today that would lead to that? So present value is a very useful concept. This is the format economists use. It's the little formula. So your utility over time is going to be your instantaneous utility. That's instantaneous utility. Utility now, utility in 1 period, utility in 2 periods, utility in 3 periods. And to account for time, you're going to divide by 1 plus r to the power of however many periods in the future you are. And in this case, r is going to be the bank's rate of return, or else it's going to be a rate of return that captures the bank's rate of return and uncertainty and inflation and anything else that is going to change your value for something over time. So that's a quick overview on why economists use discounting, why things are worth less in the future than they are today, and why the concept of present value really is just saying, okay, if you're telling me I can get $100 in a year, what dollar amount received today would be exactly equal to that? So it's really us as economists trying to make the revealed preferences match the utility. We would like to say, okay, receiving $95.23 today is the same as receiving $100 in a year. We're really just trying to make that happen. So I hope you found this useful. Time discounting is an essential concept for all economists. Anytime you're dealing with time, you want to be thinking about how should I be discounting this and what is the appropriate discount rate.